Forensic science plays a crucial role in criminal investigations, providing scientific evidence that helps law enforcement agencies solve crimes. One essential aspect of forensic science is drug analysis, which involves identifying and analyzing controlled substances. Drug testing in forensic labs is critical for several reasons. First and foremost, it helps determine if a crime has been committed. The presence of illegal drugs can be evidence in cases related to possession, distribution, or driving under the influence. Accurate drug identification is paramount. Forensic laboratories employ a variety of tests to identify drugs accurately. These tests help ensure that individuals are not wrongly accused based on misidentified substances. Forensic drug analysis is also vital for public safety. By identifying the types of drugs circulating in a community, law enforcement agencies can better understand drug trends and develop strategies to combat drug-related crime. The Scott reagent test is a valuable tool used in forensic drug analysis to presumptively identify cocaine. It is a color test, meaning that it relies on a color change to indicate the potential presence of the target drug. The test is relatively simple to perform and requires only a small amount of the suspected substance. To perform the Scott reagent test, you will need Scott reagent, which is typically prepared in two parts. Scott reagent part A consists of cobalt thiocyanate dissolved in water and glycerin. Scott reagent part B is concentrated hydrochloric acid. These chemicals should be handled with care as they can be corrosive and hazardous. Before beginning the test, it is essential to wear appropriate personal protective equipment, including gloves and safety goggles. Place a small amount of the suspected cocaine sample on a spot plate or in a small test tube. Add a few drops of Scott reagent part A, the cobalt thiocyanate solution, to the sample. Observe the sample closely. If cocaine is present, the initial reaction with Scott reagent part A will produce a blue precipitate. Next, add a few drops of Scott reagent part B, the concentrated hydrochloric acid, to the sample. If cocaine is present, the blue precipitate will dissolve, resulting in a clear pink solution. Section 4. Understanding the Duquenois-Levine test. The Duquenois-Levine test is another color test used in forensic drug analysis, but it is specifically used to presumptively identify marijuana. Like the Scott reagent test, it relies on a series of color changes to indicate the potential presence of the drug. The test is particularly useful for detecting marijuana in plant material, such as leaves and stems. To perform the Duquenois-Levine test, you will need Duquenois reagent, which is prepared by dissolving vanillin and acetaldehyde in ethanol. You will also need concentrated hydrochloric acid. You will also need chloroform. These chemicals should be handled with extreme caution, as they can be flammable, corrosive, and hazardous to health. Section 5. Step-by-step guide to the Duquenois-Levine test. Begin by placing a small amount of the suspected marijuana sample in a test tube. Add a few drops of Duquenois reagent to the sample and shake the test tube gently to mix the contents. Next, carefully add a few drops of concentrated hydrochloric acid to the test tube. Observe the sample closely for any color changes. If marijuana is present, the solution will turn purple. Finally, add a small amount of chloroform to the test tube and shake gently. If marijuana is present, the chloroform layer will extract the purple color, forming a distinct layer at the bottom of the test tube. Section 6. Forensic testing and safety, a vital reminder. The Scott reagent test and the Duquenois-Levine test are just two examples of the many tools and techniques used in forensic drug analysis. These tests play a crucial role in identifying controlled substances, providing valuable evidence in criminal investigations. It is essential to remember that these tests are presumptive and should always be followed up with confirmatory tests, such as gas chromatography, mass spectrometry, to definitively identify the drug. Furthermore, safety is paramount when performing any chemical test. Always wear appropriate PPE, including gloves, safety goggles, and a lab coat. Work in a well-ventilated area or under a fume hood to minimize exposure to hazardous fumes. Dispose of all chemicals and materials properly according to local regulations.